This project is about IEEE 802.15.4 MAC layer. IEEE 802.15.4 is a global standard for low data rate wireless personal area networks. And these kind of networks are um, used for transmitting data over short distance wireless network technologies such as Zigbee, Bluetooth, and wireless USB. And one of the main points of these kind of networks are saving energy. In this part, I briefly review the MAC protocol of the slotted mode of IEEE 802.15.4 standards. First, let's look at the time structure of a slotted IEEE 802.15.4. In according to this picture, in the slotted mode, a coordinator periodically transmits a beacon to identify its networks and synchronize the nodes. So we have two beacons here, and the distance between these two beacons are the name of this is beacon interval, and beacon interval has two parts. The first part is active period part, and inactive period, that is optional. And active period of the superframe further consists of a contention access period and contention free period. In CFP, or contention free period, the coordinator controls the channel access by, by giving a guaranteed time slots, or GTS, to each node which requests. And but in CAP, or contention access period, uh, the slotted CSP allows each node to access the channel using CSMA CA algorithms. So we have two parts: active periods and inactive periods. In this part, we said that the main point of this kind of network is um, saving the power, saving the energy. So we need inactive period to save the energy, because in these periods all the nodes are in sleep mode. And in active period we have two parts, CAP and CFP. The CAP, all the nodes here compete each other to access the channel, but in CFP, the coordinator gives each channel a guaranteed time slot, or GTS, so they don't need to compete each other. This is on this part, I mean CAP, or contention access period. And so according to this diagram, in the slotted CAP, or CSMA, when a node has a new data frame for transmitting at MAC buffer, at first it initialize these three parameters: NB, or random backup stage experienced, that the initial value of this parameter is 0. Contention window, or CW, uh, which is the default value of it is 2. BE, or current backup exponent, and its default value is 3. Then the node selects a random backup counter value from this window. So each node select a random number from this uh, window. Then this backup counter value is, or this random value is decrement by one for each backup slot regardless of the channel state. So regardless of channel state, this number is decrementing by one. And when this random value reaches zero, the node go to the next state, which is perform carrier sensing of CCA, or clear channel assessment. After that, um, the node checks the channel that is idle or not, or busy or not. If the channel is idle, the CW, or contention window, is decremented by 1. And if the CW is equal to 0, uh, then the node can transmit the packet successfully. If not, the node performs the following CCA at the next buffer back of slot boundary. And in this part, if the channel is not idle or if the channel is busy, the node will return to the next backup stage, and it will increase the value of NB and BE by 1, and reset the contention window value to its initial value of just 2, and select a new random value in this window, and then this procedure is repeated until the packet is transmitted successfully. Model that is a single hop wireless sensor network consisting of these parts: a coordinator and two kinds of nodes, M1 nodes and M2 nodes. M1 nodes have higher priority, and they use CW equal to 1, and we call them class 1. M2 nodes are low priority nodes, and they have default CW equal to 2, and we call them class 2 nodes. In other words, this paper analyzes CW based service differentiation models. That this is our model. Two Markov chain model for class 1 nodes and class 2 nodes. The difference between these two models are these states. And according to this picture, the model for class 1 nodes, the node leaves the idle state when it receives a packet for transmission with the probability of Pn1, and then it will go to the back of stage 1, and it would spend the back of state it would spend the random number of backup slots, and when it reaches the 0, it will go to the CS11 state, which is corresponding to performing the first CCA. And if the channel is idle in the first CCA, which occurs with this probability, The class 1 node would enter the transmit state or TX and start transmitting. Uh, and if not, it will go to the next backup stage and go on. Markov chain model for the channel, which has these states: idle states, idle busy states, and success 1 and 2, failure 2, failure 1, and failure 1 and 2. Um, in order to explain the procedure of this Markov chain, when the channel is in idle busy state, it may transition into three states. These three states. Um, First of all, if we go from this state to idle state, uh, or we go from this state to idle states when none of the class 1 nodes begin the transmission with this probability. And we go from the idle busy state to the success 1 state when a single class 1 node begins transmission in the current backup slot. And we go from the idle busy state to failure 1 if at least two class 1 nodes uh, begins transmission in current backup slots and the collision occurs. Collision for at least two class 1 nodes. Also, when we are in idle states, we will it may transmission into these five states: success 2, failure 2, failure 1 and 2, failure 1 and the success 1. For example, if we go to when only one class 1 node transmits while all remaining nodes abstain, we go to the success 1 state. Or when only one class 2 node begins transmission in the current backup slot, and the other nodes don't, we go to the success 2 state. And also we go to the failure 1 and 2 when a collision occurs between at least one class 1 node and one class 2 nodes. And we go from idle to failure 2 when at least two class 2 nodes begin transmission at the same time and the collision occurs between these two. These results: throughput, packet arrival rate, and probability of access of the channel, and the packet arrival rate. And according to these two results, we can see that there isn't any noticeable difference between the procedure of class 1 nodes and class 2 nodes, especially in these values. And in other words, we can came to the conclusion that CW based service differentiation doesn't have any noticeable effect on the throughput and results. So yeah, that's it. It doesn't have any noticeable effect on our results. And this was my project, and these are the papers that I've read. So, thank you.